This is problem number 5 for assessment number 4. In this problem, they say find f inverse and identify the domain and range of f inverse. As a check, show that f of f inverse of x is equal to f inverse f of x equal x. Let's start by finding the inverse. To start, we always set y in for f of x, we substitute in, equals x plus 2 over x minus 3. And then we're going to switch the x and y's. So I'm going to say x equals y plus 2 over y minus 3. Now I'm going to solve for y, and you'll notice that I have y in both the numerator and the denominator. What I want to do first is I want to multiply the entire equation by y minus 3 over 1 to cancel this denominator. On this side it cancels, you're left with y plus 2 equals, on this side you get x y minus 3 when you distribute it to this side here. Now we want to isolate the variable on the same side. We're trying to get y by itself, so we want to move this y over, and at the same time we're going to distribute. So let's distribute the x, and we get xy minus 3x equals y plus 2. I'm going to subtract y to this side. I get xy minus y minus 3x equals 2. I'm going to add the 3x to the other side so I can isolate this y over here. And I end up with xy minus y equals 2 plus 3x. Now I got y in both terms here. I can factor out a y, and I get y is x minus 1 equals 2 plus 3x. So I'm going to divide by x minus 1 on each side. I end up with y equals 2 plus 3x over x minus 1. This is the inverse, so I'm going to write f inverse is equal to, I should have put an equal sign here, I'm going to do this, equals 2 plus 3x over x minus 1. Now, what's the domain and range? So for the f function, let's look at the f function, f of x. Its domain is going to be any number except for 3. We can't equal 3. So its domain for this, because it's rational, we can't plug 3 in because we can't divide by 3. Or sorry, divide by 0. So when we put 3 in, that's 3 minus 3, which is 0, and we can't divide by it. So our domain is for the f function is going to be negative infinity up to 3, not including it, union 3 to infinity. Now the range for the f of x function I'm going to hold off on, because there's a slick way to do this if we look at the f inverse function first. So the f inverse function, its domain, well, its domain is going to be, if we look here, it's going to be any number except for 1. 1 minus 1 will give you a 0. You can't divide by 0, so we're going to have negative infinity to 1 union 1 to infinity. The range of this, now we know inverse is the range in the domain switch. So actually the range of this function, the inverse, is going to be the domain of this function. So we're going to say this is negative infinity to 3 union 3 to infinity. So that's just using like common knowledge that if we have an inverse, the domain and ranges are flopping, which means the range of this function, the f function, is the domain of this function, which is negative infinity to 1 union 1 to infinity. Last step, show that f of f inverse of x equals f inverse of f of x, which equals x. So we can kind of do this at the same time. F inverse of x is this function, and it's being plugged into the f function here. So I'm going to kind of do it at the same time just because I don't have a lot of space. So I'm going to say that this is 2 plus 3x plus, or over x minus 1 plus 2 over 2 plus 3x over x minus 1 minus 3. So I took the inverse function and I plugged it into the f function. I'm going to say that that's got to equal the inverse, or the f function plugged into the inverse. So let's take the f function and plug it into the inverse function right here. So we're going to say 2 plus 3, and then we'll have x plus 2 over x minus 3. And that's going to be over x plus 2 over x minus 3 minus 1. So you can see that we plug the f function right here into the f inverse function here. Now, how can we show that these are the exact same? Well, I can multiply by x minus 1 over x minus 1 to this fraction, and I can multiply by x minus 3 over x minus 3 to this fraction, right? X minus 3 over x minus 3 is 1. So when I multiply, I get this denominator going to cancel because I get 2 plus 3x. And then I end up with plus 2 times x minus 1 because I distribute the x minus 1 to the top term. On the bottom, that same thing occurs, so I get over. This cancels, I get 2 plus 3x minus 3 x minus 1. And that's going to equal, on this, that cancels, and I distribute to the 2, so I get 2 x minus 3. And then this cancels, so I end up with plus, so I'm actually going to distribute this 3. I'll get 3x plus 6, so plus 3x plus 6. Right, this cancels here. I distribute the 3 over, down here this will cancel the bottom denominator, leaving you with x plus 2 minus x minus 3. All right, let's do some canceling here. When we combine stuff on top, we end up with 5x, right? 2 times x, that's 2x. Combine that together, we get 5x. 2 times negative 1 is negative 2, and 2, they cancel. Like this 2 will cancel with the 2, distribute to the negative 1. So we end up with 5x over, on the bottom, same thing occurs, except for the negative 3 gets distributed to the x, that cancels here. Negative 3 times negative 1 is positive 3, which we'll add with the 2, we'll get 5. And that equals, on this side, we end up with 2x minus 6, and the negative 6 and the 6 will cancel, and we end up with 5x on the right side over, this will give you negative x, so it cancels this x value, and that'll give you, when you distribute the negative, a positive 3. Combine it with the 2, you get 5. So you end up with this cancels, and that's x equal x. And that proves that that is true. Now, this is a little bit of a short version because I was out of room, but definitely play around with that and practice it.